Look at all these series. All of these are series. I don't know. It doesn't say that in the directions, but these are all series. They are sequences that are being added together. You see, this is a sequence. There's a pattern right here, and they're all being added together. That makes it into a series. It's taking a sequence and turning it into a series. So this says use sigma notation to write the sum. So in order to do that, first let's write our sigma. There he is. Okay, now the bottom number is the number that you start with. Normally, well, you can start with any number. I think this one they want us to start with 1. Oh, they don't tell us, but we're going to try 1 right there. And then inside the sigma, that's whatever you write next to it, that is going to be the rule. In our case, the nth term. And then the top number, this is the number that you end at. Okay, end. That's the ending number. It looks like for this very first sequence or series that we see, we're going to end at 9, and the first number that you plug in is 1. So we would be good to start at 1, and then we would end at 9. Okay, so all we have to do is come up with the nth term and then throw it into a sigma. Okay, this one right here is pretty obvious because they don't multiply out the denominator. This one right here, you can see they don't add the denominator out, so you can see what the pattern is. It's just a 1, and it looks like first you add a 1, then you add a 2, then you add a 3, so that's going to be this guy right here that's getting plugged into it. The guys like this, you're going to have to figure out what the pattern is. But let's go ahead and let's do that one. Let's figure out what the pattern is. Let's define an nth term for that guy and then plug him into sigma. Okay, so I can see that the sign is alternating. All right, so that means I'm going to need a -1 raised to the nth power. Okay, that'll alternate the sign. But actually, if I plug in a 1 for the n, that would be -1 raised to the 1 power, which would keep the first term as negative, but it's not supposed to be negative. So let's make this a n minus 1. That would make this a 0 when n equals 1. All right, cool. Now let's do the rest of the rule to get the other numbers. So it looks like we start at 3, and then we go to 9, and then we go to 27, and you go to 81. Notice I get to ignore the negatives now because I already took care of the negatives. If we're starting at 3, let's say that this is going to be 3 raised to the n power. So if we plug in 1 for our a sub 1 term, first term, would that work? Let's see, we would get a 0 for that, and that would make that into a positive 1. And here we would get a 3. That would definitely give us the first term. Okay, and then for the next one, I just want to test 2 times. Okay, let's see if it works. We plug in 2, so it would be 2 minus 1. And then over here on 3 to the second power. 2 minus 1 is 1, so that's going to be a -1. And 3 to the second power is going to be 9, so we get -9, which is exactly what we get for our next term. Okay, now let's plug it into our sigma. So let's write our sigma. We'll go ahead and start at I equals 1. You can start at a different number, but I'm going to start at I equals 1. And then my rule is going to be raise the -1 to the ith term minus 1, right? Because that's what we decided, n minus 1. And then we're going to take 3 and raise him to the nth power. Oh, not the nth power, haha, the ith power, okay? And then how many times are we going to do this? When is this guy going to end? Let's see, 1, 2, 3, 4, 5, 6. So 6 times. 6 would be the last number that we plug in, and that'll be it. You don't actually have to find it. It just says write it in sigma notation. Okay, some of these have ... so that means you're going to have to figure out what term would give you 128, or what term would give you 20, so on and so forth. All right, good luck, guys. Turn those brains on.